stabilize chiral domain walls and enable extremely efficient current-driven motion, and this has been confirmed by other papers. There are some complications that I don't want to discuss, but there are simple signatures. For example, in the situation of a left-handed nail wall, depending if the nail is between down and up or up and down, this lateral field, longitudinal field, will stabilize the dilation. We help the dilation-schema interaction or compete with the dilation-schema interaction. And L, that means this corresponds to this effect, these positive slopes, yeah? And conflicts correspond to the negative. So there are several signatures that maybe will be discussed in the next talk. And in fact, I want to compare with, in fact, the situation is very similar to the situation of Skirmion. In fact, it's not surprising that we obtain large velocity in both situations because we are more or less in the same situation. In fact, what is along this axis, what is a Skirmion, is an association of two nail domain walls. And so it's not surprising that we are obtaining the same good situation. So next, for spin orbit induced and charge spin conversion. So there is a lot of things to study with topological insulator. We have seen some examples this morning. Graphene and other 2D material. I can conclude with two slides for graphene to say that there is a lot of things. Graphene, you will say, spin orbit coupling is very small on graphene. But it can be, strong spin orbit coupling can be introduced by adatoms or by proximity effect, adatoms or layers of platinum or these sort of things. And for example, simply to summarize what can be obtained on graphene by introducing. This is the first experimental result I know is this one by the group of Barbaros Zinmax in Singapore. And so by hydrogenation, they introduce by hydrogenation, that is by mixing some sp3 character into the sp2 character of the pi band of the direct electrons. They are introducing an spin orbit effects, a sort of skew scattering that can be detected by giving rise to a spin currents, a spinol effect, a spin current here, by spinol effect, and that can be detected by the inverse spinol effect and seen by a voltage between these two ends of the stripe. So they are interesting experimental results, and many other type of interesting effect can be also obtained. In fact, this was the introduction of small concentration of hydrogen. That means only very local spin orbit center, like skew scattering impurities. And in fact, many theoretical papers have investigated a situation where a more uniform Rashba coupling is introduced by proximity onto the graphene. And then we have the classical Edelstein and inversion electron effect. That is, for example, a charge currents give rise to a non-zero spin density and also to a spinol effect like that. And other more complex effects can be expected. For example, if you introduce this proximity effect, not uniformly but only locally, what can be called a Rashba barrier, then these barriers are very interesting property of